Hello, and welcome back to the Online Brain Intensive. My name is Sarah Kimmick, and today we're going to be talking about rapid rounds for reproducible science. So, my background is originally in human factors engineering, and it was a huge part of what motivated me to do this course. Neuroimaging is the field that I'm in now. It's fascinating work to be involved in, but a lot of times I see very technically sound research being influenced by human factors. And in other fields, we've already worked out techniques to be able to deal with some of the issues that crop up. And I'm going to talk to you today about some strategies that you can work with. The second, we're going to address specifically the human factors that come up in OBI projects. A lot of you guys are working on collaborative coding projects with people that are distributed around the world, and that can give you a unique set of factors that you're going to have to deal with. And a very good way to solve it is doing a thing called rapid rounds. These are 20-minute periods where you're really focused with your entire group on solving specific aspects of your problem, and we're going to talk you through how to do that today. So, first off, if you don't take anything else away from this today, I think what you need to know is that human factors really matter. So before I came into neuroimaging, I got to work on really cool problems where we were interested in understanding how people share information between each other and the environment. So I got to ask questions like, what's the best way to prompt a jury in order to have a fast and fair deliberation? I also got to work on Boeing cockpit alert systems, trying to find the best way to have shared information between a pilot and co-pilot. And most recently, I've been using human factors engineering in data viz challenges. It's a very cool environment where we have around 100 software engineers and data visualization specialists come into a room. They are totally naive to the problem at the onset, and over 2 hours they go from working with raw data to producing a novel result. Now, these people have to learn to work with strangers and to get rapidly developing a product in a very short amount of time. And it's from working in that space that I came up with some strategies for collaborative coding that I think will be very useful to you. So the three takeaways from all three of those environments are this. These are what have come into this course. If you're working in teams, you want those teams to be around 4 to 6 people. That's the amount of humans where you'll have the maximized information transfer between each person. You'll just have better communication. It's just fine if you have a group that's smaller or larger, but do note that if you have a larger group, it's very likely that they will break down into smaller nodes of highly connected groups of 3 or 4 individuals, and you might not all necessarily be working on the same problem on the same page. The second is to make shared information more visible. Most humans are incredibly visual thinkers, and a lot of times we're working on these very abstract software problems. I'm going to encourage you strongly to just take out a pen and paper and jot down these more abstract ideas and make sure that everybody is looking at the same information. It can really save you a lot of time. And the third is to commit to doing rapid iterative code development using rapid prototyping. It can be a challenge to really stick to learning to work on a 20-minute timetable, but I've seen it be the most effective for shared coding environments. So, what are the human factors that come into these into your online brain intensive projects? For the most part, even reproducible science can be bad science, and you'll see that for 4 reasons. Sometimes it comes into just the base theoretical motivation behind the project. What was the motivation behind your hypothesis? Second, what is the research design that you've chosen to go with? Most of you aren't engaged directly in the data collection for these projects, but for you to think of research design in this setting, in some cases that's as simple as, is the hypothesis that I'm trying to test good for this data set, or vice versa? Is this data set good for the hypothesis I'm trying to test? The third is statistical analyses. Now, I know that these can be straightforward for some of the problems that you're looking at. It might seem simple that all you'll need to do is a t-test. But I would encourage you to still spend a little bit of time with your entire group thinking over, is there a better way to do your statistical analyses? Or do I just need to more clearly state what the motivation was behind those analyses? And the fourth is encoding development. This is really the major human factor that you're probably all going to be running into, whether you're working with people that are physically close to you or 1,000 miles away. Most of the shared information that's going to be technically useful to you is going to come in the form of these git commit messages. You're going to have to be able to clearly communicate what the valuable change that was made in your software, not only to other team members and other teams, but to yourself a year from now. You want to be able to know that what you wrote down in that 100-character little line is useful. So, is there a systematic way to go about doing that? There definitely is, and it's a method called rapid rounds. This originally comes from work done by Tom Chi. He's by far my favorite human factors engineer. He originally developed the Google Glasses and quite a few other really innovative products for Google, but he was very interested in going rapidly from having an idea to a product in hand. Now, I've had a chance to work with him in a couple of workshops, and I said, hey, this is incredibly useful. I'd really be interested in seeing this being utilized more in software environments. I told him that I would love to bring this into this course, and he gave me a full go-ahead. So he's very happy to see this rapid prototyping being brought into the scientific environment. And if you've got more questions, I would encourage you to look into some of Tom Chi's work. So what we're all working on are just at the base level a problem over an unlimited domain of possible solutions. So at the onset, you'll say to yourself, I want to work on sex differences, or I want to create a better pipeline for this signal-to-noise problem. You start out with that, and then you have to work over time from going to just the idea to an actual result, how you went about solving that problem. And you can do that iteratively by having small, testable hypotheses that you'll slowly develop into a constellation of good ideas. The whole goal here is to be able to work over this domain of possible solutions and testable hypotheses as quickly as possible. And you want to spend really as little time thinking instead of doing as possible. So how do you do that? Well, first, let me go through this slide. Rapid rounds are this form of prototype thinking that are meant to minimize conjecture during research design, meaning it's meant to minimize how much work you do based on assumptions versus observable elements. It's supposed to also maximize this incremental, improvable observements that you're seeing in your design, analyses, and coding, and it will help you, I guarantee, to maintain a clear and communicable record of progress. So we do this by doing 20-minute sessions broken up into small rounds of 3 minutes, 7, 5, and 5-minute rounds. And it looks like this. So let's step through each session of this. The one thing that I do want to state before we start is that I found it's incredibly important to actually put up a timer on the screen. So you're going to need to have some time where you have all individuals or as many individuals on your team available at one time to discuss every aspect of this. And I guarantee you that'll be the best way to maximize both involvement and really progress, just making sure that everybody is engaged and bringing all the knowledge that you have to this problem rapidly. So the first thing to do is to spend about 3 minutes discussing the problem and the possible solutions to that with your group. It might seem like a wasted aspect if you already know that you're trying to solve one little coding problem, but I guarantee you just making sure that all 4 to 6 people are working on the same problem at once can save you a lot of time. Once you've decided what you're working on, whether it be some aspect of your research design or your analyses, then you're going to spend 7 minutes working specifically on that problem. So when I say that you're going to have to develop a demonstrable representation of that solution, you're going to have either a document that walks through your research design, a document that walks through your statistical design, or you're going to want to have actual code that somebody can look at. Once you've got that, spend that 7 minutes And then this is really the important step, and this is the step that it sometimes takes a little bit of convincing for scientists to take on. After you've done this 10 minutes of addressing a problem and developing a solution or a version of a solution, you want to immediately give that away to somebody else who is not a part of your group. Now, this can be an email to somebody on another team, or this can be just somebody else that's in the room. They don't really have to be a scientific expert in your field in order to give you valuable feedback. When you give them this either sheet of paper or this code or a git code and commit, you want them to be able to tell back to you what your motivation was, what that 3-minute sort of question that you were trying to look at. They should be able to tell you what that was. Your solutions should be close enough to the problem that you're trying to address that they can just straight up tell you you're trying to do research design for this hypothesis. If they can't do that, then you're going to want to go back to the drawing board and spend another 10 minutes working on that. But I can tell you, doing things in these really short 20-minute bursts can save you a ton of time. I've seen things get picked up and red flagged doing this 10-minute iteration that wouldn't have come up until you got to peer review. So this is a way to really save yourself time and make sure that you're catching these little assumptions that you can't even see yourself. And then fifth, right after you've gotten that feedback, revise the model that you've developed and make a very small presentation. For most of the times I use this method, it's just bullet points of the pros and cons, what went well and what went wrong. Once you've got that, you can go ahead and do another 20-minute round on that issue, or you can move forward and start with another aspect. So in order to make this a little bit easier for you guys, I've developed a page on the website itself called Rapid Rounds. You'll be able to fill in each aspect of this, and we'll give you feedback on if you're doing it correctly or what you could do to improve. But I'd really encourage you to do this 20-minute Rapid Rounds on at least, at minimum, these 3 aspects. Do a rapid round with your group where you decide what is the theoretical motivation behind your project and spend 20 minutes really working on that. Spend 20 minutes doing a rapid prototype or a rapid round on your research design with your entire group involved, and another 20 minutes doing a rapid round on your statistical analyses independent from your research design. I guarantee you that that hour will be one of the most productive in your project's timeline. After that, you can use these rapid rounds, and I usually use rapid rounds during coding development in order to sort of reduce fatigue and make sure that you don't sort of get distracted in your code. If you're trying to solve one problem, have everybody working on that problem. Most importantly, though, have fun out there. These are challenging projects. They are going to take a bit of time. I think that these rapid rounds will improve your working experience, but if there's another method that you'd like to take, or if you already have a working rapport with your group, I'd encourage you to take whatever strategies allow you to do reproducible science well. These are all just suggestions. If you have any questions, I will be available on Slack or by email at onlinebreadintensive@gmail.com. I'm really impressed by the projects that have come through so far, and thank you guys for taking the time to take this course.